About that, guys, I'm back, and I think we were trying to mutate this list here. I'm not printing anything, so let's print this list out now. Yeah, so as you can see, when we declare this list, we actually have something else in that instance, right? We are actually having this list here converted to this list. We can mutate it anytime we want after declaring it, right? This is called mutability, and it is a very essential property of a list. I hope you understand that, and there are a lot of methods that we will be discussing that in which we can use mutability. For example, append is one to name, and so on. There are a lot of them, and we will be discussing in the next video. So in this video, the last thing I want to discuss is the copy of the list. And not sure why is it here now. So can you make a copy of a list? Yes, you can. Can I do this amino? Yeah, you can do. You can do anything. So why is it not a copy? Because we are actually declaring two different variables with two different instances. This is not a copy, guys. This is actually declaring two variables in different lines, in different statements. So what does it mean to make a copy? Making a copy means that we are actually assigning the same values of these and making the same instance or binding that instance to another variable. So in simple language, let's say this has an address, right? This instance has an address. Now when we are using an assignment operator, it's actually binding that address that this instance has to this variable as well. So both these the A and the B both must have the same address. Can we prove that? Yes, we can. Let's just print the ID here. Why not, right? We have the ID function. Let's use it. So as you can see, both the addresses are same. That's amazing, right? We are actually binding an address to the variable. So that must be really, really clear to you guys that what we are doing, that we can actually mutating this value here. I hope you got that we are actually assigning another value to the first element amino here, right? So we changed the value from amino to code. We printed the value A and we got the required answer that yes, amino, this was the answer. But this is where it gets exciting. When we are printing B, we are also mutating the same. We have also mutated the variable B here. Why is it that? Because they both have the same addresses, guys. They are actually pointing at the same thing, same object, right? So you can actually understand that like an box. Let's say this is a box here and we have A here, and actually it's pointing at this box, and B here is also pointing at this box. Whenever we access this A and this B, they're actually accessing the same box, right? So I hope that it's a little bit clear, and if you don't understand that, don't worry, I'll make sure that I will make this clear in another video when we will be discussing about tuples, right? So now the second thing is that shallow copy. We don't want this every time, right? We don't want to actually append every element whenever we make a copy. Sometimes we just want to append the A list and not the B one. How can we do that? The first method that we use is the shallow copy. So there are three ways of actually making a shallow copy. This first one is copy. The second is list copy. Third one is using slicing. This is a method here. I hope this is going to be your guys. So yeah, for using copy here, this copy, we have to actually import this library and called copy only. Don't worry about the import statement right now, just print it, sorry, just write it down. Remember this. Okay, so we are actually importing another property from some other code and printing out or making a copy of A into a B. Now, as you can see, this will actually make a copy of A. Not very impressive, I guess now. But, so what this will, what is this that we are achieving here? Now, as you can see, whenever I append A here, the B element that we made a copy of does not get appended. Does not get mutated. I actually used appended. I'm sorry, guys. So as you can see, it does not get mutated. It does not get changed. So this instant, both these instances are actually different, are actually pointing at different boxes. All right. The same is true for list copy. This is a shallow copy, and the slicing. Now you must be wondering that this was actually the aim of the problem was solved, right? The aim was to remove this problem of making the references to a similar object. Now the issue is, what if we actually point at a list inside a list? This fourth element is actually pointing at a list and it is containing a box. So there is a box inside a box, right? A box inside a box that has two references. Now, if I print it out, as you can see, if I append this one here, it's appending both of these. This is the issue in shallow copying, guys. This is really essential concept, and I am taking my time here to make you understand that this here, what we are doing is we are actually mutating this list, the one at the third index, right? And we are changing one value here, and it's actually changing the value in the other list too. Right, this is why it's called shallow copy, or a copy from only looking at the parts above and not inside them. Now we actually have arrived at the last concept of this video, and that is the deep copy. This is really essential, and as you can see, we actually make a copy of each and every element so that it doesn't have an address of its own. So everything from this list to these lists has those instances that have each and every have single and distinct addresses. Now if I append this one here, it won't mutate the other one, the other list inside the B here, the list B here that we made using the deep copy method. So I hope that everything from beginning to end is clear, and we have covered a lot in this video, and I'm hoping that you got everything. We took the time. And for the quiz, guys, in this video we will be giving a quiz to you so that you can research about it and comment it out. So I have something interesting for you guys. Now Python is a language, it's actually, we are accessing computers here. We are talking about computers, right? So let me give a quiz here, and you have to answer those in the comment section, guys. If you don't want to, that's up to you. All I want is you to research about these things. So this is something really important in float arithmetic. 1.2 minus 1.0. What is that, guys? 0.2. Well, yeah, simple arithmetic, dude. What is so? Why are you letting us research this part? Now, the main issue here with Python is it's broken, I guess. It's giving me some weird values here. As you can see, it's not providing me 0.2. I want you guys to research about this, that whenever I type some floating values, it happens with floating values, guys, and not with integers. So this is another example. I'm adding actually 0.1 to 0.1 to 0.1. What would be the result, guys? Guess it. And I think most of you would not have guessed this. So is it equals to 0.3? No, guys, it's not. It's false. This is the part I wanted to discuss. Research with your friends and comment it out. If you don't get the answer, I'll make sure to make a video on this too. Right? Tada, guys. Have a good day. Thank you.